Okay, for this module, we're going to start talking about circulations. They come in all different shapes and sizes in the atmosphere. There are massive ones that deal with circulations that the whole atmosphere has as a whole. So you've learned all about some of the variables that go into making the weather. Well, now you're going to put them together and begin to talk about the circulations that develop from those variables. We know, for example, that the Earth heats up more at the equator than it does at the North Pole. Well, because of that, the air is hotter at the equator. It's going to want to rise. We know the Earth doesn't like temperatures to be different, so it's going to try to push that warmer air up to the north and the cold air from the north down to the south. And what do you wind up with? A massive circulation, right? If the Earth didn't rotate, that's what we'd have. But the Earth does rotate. So it actually divides up that circulation. So let's take a quick peek at the circulation right now and look at the atmosphere and just see what is going on over the world a little bit. I'm not going to get too fancy here or anything, but I just wanted you, let's take a look at this over a big picture. All right, we have high pressure up here in Canada and one right here. This is an air mass, and typically high pressure, part of the atmospheric circulation, high pressure tends to develop in this area. Notice all the lows across about 60 degrees north right here. One after the other after the other. Very typical of the whole atmosphere as a whole. Oh yeah, there's another high pressure system probably sitting out here on the edge of the Atlantic. There's also a weak low off of Florida right now. But that's the basis of the atmospheric circulation. Around 30 degrees north, we get high pressure. 30 degrees north of that, basically around 60, we get low pressure. And then up over the North Pole, we typically have high pressure. So if you look at that, these are massive circulations that the Earth develops from the variables, the differential heating, the rotation that's going on, the changes in pressure that are caused by all of that. And they're constant. There typically is going to be high pressure somewhere across 30 degrees across the Atlantic. Now, yes, there may be a storm that moves through there. But if you look at it as a whole over the whole year, you're going to get a lot of high pressure right there. And these things develop massive circulations. Did you know that there's a monsoon in the United States? It occurs in the Southwest. And we've actually had some here where high pressure develops. Low pressure actually forms because of the heating out here, pulls in moisture from the Gulf of Mexico and from the Southeast Pacific into it. And what do you wind up with? You wind up with lots of rain and clouds in the summertime. By winter, that's monsoon has gone. There are monsoons that occur over in India. There are monsoons that occur over in the Arabic countries. All of these different things are based on global weather patterns, big scale. So now we're going to start bringing this all down. You notice we have a front right here, down across just north of Florida. So we're going to start talking about fronts a little bit and narrow down our focus some. So let's just think about, there's high pressure coming down here. Here's the most latest one. It's kind of centered over New England. What do you have here? The front just north of Florida. There's low pressure off of Florida, actually. Another cold front, low pressure out in the Midwest. These are differences in air mass. Take a look at this cold front here. 54, 56, 78, 72. Dew points in the mid-60s. We talked about dew points being moisture. Lots of moisture. This is probably a tropical, a moist air mass coming up here, being led from a high further south. This is a continental polar, maybe even maritime polar, coming in off the North Pacific. So there's a change in air mass right along this boundary. Oh yeah, and these boundaries, they're not one-dimensional. Don't think that this cold front is right here or that this warm front is exactly here. If you're in a plane flying north out of Oklahoma City heading up to Madison, Wisconsin up here, you may not hit this warm front until up here in the northern part of Missouri. So you can see, you may see that there's three-dimensional, and warm air is lighter, so it's going to rise up. You actually wind up with the warm front further and further north of where the surface position of the warm front is. Cold front wise, think about it. Cold fronts are pretty steep. It's pretty dense air. When you fly across there, you're going to quickly transition into the cold air mass. And it's going to get pretty deep very quickly if you're flying at low levels. Maybe if you're way aloft or whatever, it might take a little while for you to reach the cold air. But pretty much cold fronts are very deep, very quick. They get up to 10,000 feet thick. So if you were flying out of Florida here, you'd hit this cold front here. You would quickly go in to much cooler air. Notice the wind shift. The winds are out of the northeast here. Dew points are in the 50s, and up here at my house we're in the 40s. We're in Florida, mid 70s, coming off the ocean. Very much a change in air mass right there. So now that we're talking about this and we're dealing with air masses like that, let's move on to, we just talked about cold and warm fronts. If we go back to that chart, here's almost a stationary front. Notice warm, cold symbol, warm symbol, cold symbol. Notice where the high is. The winds are going to be from the east right here, right? There's no push to make this move south. It has an equal amount of push from the warm air, and it has an equal amount of push from the cold air. So the front's not moving. That's a stationary front. So the next thing we're going to start discussing with these fronts is we want to know when lows are going to form. Think about it. There's a big low out here. Lots of northwest flow here. Well, what's going to do? It's going to push that cold front southward. If you're on the east side of a low, what are you going to get? Lots of moisture coming up from the south, probably, especially in the U.S., and maybe some warmer weather, like a warm front here. So if you're flying around here, you've got to be aware of all the different variations. If you have northwest flow, you may have snow, maybe even some icing considerations up here. Oh, on the other side, on the warm front side, maybe you'll be dealing with thunderstorms. Oh yeah, and the clouds. If you were flying down from the north, you'd probably start out with clouds, up around 30,000 feet, then gradually lowering as you're going down towards the warm front. You might have some pretty low ceilings right down here in this area. Sometimes, think about this cold front here. You may have some showers or thunderstorms right along the front. So if you were flying out of Florida and heading north, what you would be doing would be cutting across an area of vertical motion where you have the showers and storms potential. So what are we looking for to generate these extratropical low pressure systems, as they're called? Well, one of the things you've learned about in this is we're going to look at some upper air maps. I just want to look at 250 millibar. Let's start up there. So we have a low out in here. We have jet streak, one coming in off the Washington coast and one north. Where's the divergence? Well, left front, right rear. What do you got? Right rear is right about in here somewhere, over Iowa into Minnesota. The current low pressure in the Minnesota, Nebraska. So there's actually some correspondence there to this jet that's moving north. So the first piece of any puzzle and looking for where lows are going to form, you need lift aloft. You need something to cause the air at the surface to begin to rise. And the stronger that rising motion is, the deeper the low will be. So this isn't that strong, but if you were flying along, you'd be bumping around right up in here if you were flying at this altitude which is around 30 to 35,000 feet. So a lot of jets do that. So you'd be bouncy ride right there. Okay, another area is with this as well. Let's look lower. So let's look at 850 millibars. It's not a closed circulation, but there is low pressure there. The low, as we know, was right about in here somewhere. The actual low at 850 is further to the west. The actual low at 250 is even further north. Notice the sloping, just like we were talking about. But try to find where the moisture is coming from. I know we've had thinking about moisture and stuff. There's lots of moisture starting to come up out of the Gulf of Mexico here, kind of get a little bit pulled in. Some of it's coming off the southwest. The green lines are moisture, and they're feeding right around that warm front. So there's moisture coming with that warm front. Heat provided there, maybe even some instability to cause some showers and thunderstorms there. But there's a heck of a temperature contrast too, right in here. Temperatures on the other side of the front, and sometimes at 850 millibars is where you can really pick up on temperatures and all, and really see all the gradients of temperature. And there is a pretty good one right in here right now. So, and there's a temperature contrast out here, a lot of moisture along that front. If that front sinks any further south, North Florida is going to start getting a lot of showers and thunderstorms with it. I want to just take a look quick at how that pattern is going to change. I'm just doing 2 days, and we're going to look at a numerical model simulating the weather. But here's that low, and watch it. This is Saturday afternoon, and that low gets a little deeper, doesn't it? 992, 990, but let's stop it right there. So if we go back in time, there's a couple images here. Right here, just to the southwest. Okay, 850. Look at the temperature contrast here. Notice how this warm air, red lines are warm in this case, have spiked up into it. There's a ton of warm air coming on the east side. Notice the cold air coming on the west side, bringing cooled in. So this is temperature contrast that extratropical lows require. Now, if you go back upstairs, we just saw earlier at 250 millibars that there was a pretty powerful jet streak up to the north and out to the west. Well, the one up to the north continues on and moves out, but the one on the west starts getting mixed in here, doesn't it? It made it all the way from Washington to by tomorrow afternoon, it's sitting over Minnesota into the Great Lakes. So if I stop that, go back to that time again, you can actually see left front quad jet streak. Moisture, temperature gradient. So that is a perfect location for that low. Yeah, once this jet streak goes by, the upper level divergence won't be as strong. So, but as you can see here, that is where your low is going to be. So if we look at these lows, sometimes they're pretty strong and sometimes they're not as strong. I did want to show you one image here, a cold front. This would be taken, there was a cold front that just went through Tallahassee. Top of the cold air, maybe 1,000 feet, 1 kilometer. Top of the cold air here, over 3,000 kilometers, 3 kilometers. Just in the difference from Tallahassee to Atlanta, this is a fairly shallow cold front. Wasn't that powerful, but you can see it right there. It went on. And finally, just looking here at this jet, let's develop another low over Texas. Here comes the jet streak. And these things rotate through the atmosphere. They don't stay in one location. So you have divergence here, helping to form low pressure. Oh yeah, you can actually see the high to the north. So you probably have a cold front right in here. Similar to today, actually, except you don't have the upper level influence down there to make the low. Here's your jet stream coming out. Here's the low moving up. And here's another jet stream to the north. So actually, you might have two sets of divergence helping this to grow. So you got to think about all these pieces being put together and what you're learning. And that's the way you look at these circulations. And now we're going to get into next in 2 weeks, of more talking about the tropics a little bit, and more smaller scale circulations like thunderstorms and all. So let me know if you have any questions about this.